This lesson is on prime factorization. It is the kickoff to our unit on exponents and exponential functions. Our learning goals are: I will be able to identify and define the terms factor, prime number, composite number, and prime factorization. And I will be able to determine the prime factorization of a number. So get your guided notes ready. Our first vocabulary word is factor. Factors are the numbers you multiply together to produce a number. For example, 2 times 3 equals 6. So 2 and 3 are factors of the number 6. A prime number is a whole number with only 1 and itself as factors. For example, 1 times 3 is 3. 1 and 3 are the only factors of 3. They're the only two numbers you can multiply together and get whole numbers and get 3. So 3 is a prime number. These are the prime numbers up to 100. Don't write it down. You can always Google it if you need it, or it's on the slide. Composite number. It's a whole number with more than 2 factors. For example, 1 times 6 is 6, and 2 times 3 is 6. So 6 has 4 factors: 1, 2, 3, and 6. Therefore, 6 is a composite number. So a number is either prime or it's composite. Prime factorization. Prime factorization is writing a composite number as the product of prime numbers. For example, we already know 6 is a composite number. We know that it is 1 times 2 times 3, which are all prime numbers. So 6 has 3 prime factors: 1, 2, and 3. But since every number has 1 as a factor, we don't list it, and I won't going forward. So how do we figure out prime factorization? There's 2 main methods. There's the factor tree method and the divide by prime. You don't need to be a master of both. Try both. Figure out which one makes the most sense to you and go forward with that one. So let's look at the factor tree. So I'm going to say, what are factors of 40? Well, how about 4 and 10? And then I want to look and see, are these prime numbers? I'm going to start on the left with the 4. Is 4 prime? No. What are its factors? Its factors are 2 and 2. They are both prime. So I'm done with the 4. So I'm going to move on to the 10. Is 10 prime? No. What are its factors? Well, 2 and 5. We already know 2 is prime. Is 5 prime? Yep. So our prime factorization is complete when all of the bottom branches are prime numbers. So the prime factorization for 40 is 2 times 2 times 2 times 5. So that's the factor tree method. The other method is divide by prime. And that's when you start with a prime number, you start with a composite number, and you start dividing it by primes. If your number is even, you start with 2. If your number is odd, then you start with 3. Our number here is even, so we're going to divide by 2. 40 divided by 2 is 20. And we're going to divide by 2 again. And we get 10. And we're going to divide by 2 again. And we get 5. When you do divide by prime, when your bottom number is prime, you're done. So here we are. Same prime factorization. 2 times 2 times 2 times 5. All right, here are some notes. It doesn't matter which method you use. They both give the same answer. Use the one that works best for you. Every composite number has one and only one set of prime factors. Convention is to list the prime factors in order from least to greatest. And remember, every even number is divisible by 2. Once you have factored out 2 so that you end up with an even number, work your way through the prime numbers. Start with 3, and if 3 doesn't work, go to 5, and see if you have another factor. So let's look at the prime factorization of 424. So for factor tree, I'm going to write 424. It's even, so I'm going to pick 2 as a factor, and I get 212. 2 is prime, so I know I'm done on that one. So let's look at 212. 212 is again divisible by 2, which is 106. 2 is prime. 106 is divisible by 2, and we get 53. 53 is odd, and it is actually prime. It is not divisible by 3 or 5 or 7 or 11. So it is prime. So my prime factorization here is 2 times 2 times 2 times 53. If I do divide by prime, that's actually essentially what I just did over here. Can you tell which method I learned? 2 goes into 424 212 times. 2 goes into 212 106 times. 2 goes into that 53 times. I'm at a prime number, so here is my factorization. Notice they are exactly the same. Each method is going to give you the exact same answer every time, unless you did something wrong. So let's look at 384. I am going to do divide by prime. 384 is even, so I'm going to divide by 2. So I get 192. And I divide by 2 again, and I get 96. And I divide by 2 again, and I don't get that. Let's try this again. I divide by 2. 2 into 9 is 48. That's more like it. 2 goes into here, 24. 2 to 12. 2 to 6. 2 to 3. So I get to a prime number at the bottom. So I have 1, 2, 3, 4, 5, 6, 7 2s. So here my prime factorization is going to be 1, 2, 3, 4, 5, 6, 7 times 3. So if we did this with the factor tree, we could pick 12 as a factor. Well, what is 384 divided by 12? That is 32. 12 isn't prime, but it is even, so I'm going to divide it by 2, and I get 6, so that's prime. 6 is 2 times 3, and they're all prime. Let's look at 32. 32 is 8 times 4, but 8 is 4 times 2. 2 is prime. 4 is 2 times 2. And 4 again is 2 times 2. So I have 1, 2, 3, 4, 5, 6, 7 2s and a 3. 1, 2, 3, 4, 5, 6, 7. So you see, both methods produce the exact same answer. Use the one that works for you. Here is 832. I am going to use divide by prime method. I'm going to start with 2 since it's even, and I have 408, and I'm going to divide by 2 again, and I get 204, and I divide by 2 again, and I get 102, and I divide by 2 again, and I get 51. All right, well, 51 is divisible by 3, so I get 17. 17 is prime, so I'm done. So I have 2 times 2 times 2 times 2 times 3 times 17. That is how you determine prime factorization. I hope this was helpful. Thanks.